Hi, so today we are going to discuss about named entry recognition or NER in short form. So let's try to understand let's just imagine this like you're reading a thrilling novel and you want to quickly find all the names of characters, places, or even magical artifacts mentioned throughout the book, right? Now doing that manually would take ages, right? Well, that's where NER comes in. It's like giving your computer a pair of reading glasses that highlight all the important names for you. So let's embark on this exciting journey where we will teach our computers to recognize names of people, places, organizations, and more, and all using Python's NLTK library. First things first, as you all know, we need to have this NLTK, so we need to install it, and next we need to import it. This is the run I ran, and I'm taking example statement process. Sorry, Professor Oak gave Pikachu to Ash Ketchum in Pallet Town on a sunny Monday morning. Okay, so first let's start with tokenization. This is our code for tokenization. As you know, we need to break this sentence into words, right? So you use a process called tokenization. And if you see, those are broken into words, tokenization completed. Now let's see parts of speech tagging, which we learned earlier. So this is the code for parts of speech tagging. Let's execute it. You can see now. Don't worry if this tag seems a bit cryptic or difficult. These are actually discussed in previous session. You can refer to it. NNP stands for proper noun. VBD stands for verb, but past tense. JJ, where it is anywhere. I remember JJ. Yeah, JJ stands for adjective and so on. Okay. So POS capability is that it describes each word. Okay. Before we perform NER, we need to download some additional NLTK resources, specifically the max int, NE chunker, and the words corpus. Okay, so I'm executing this. Downloaded. And next we need to perform NER. So this is the code. We'll use NLTK's NE chunk, which we downloaded here, right? And identify named entities in our sentence. Okay. So if you see, the result came here. There is one code I tried visualizing these entities, but due to not enough resources, or I'm not sure what kind of error is happening. Actually, no error is coming. It is running for so much time, so I stopped it. You can try it at your end, but is this just for visualization purpose? I'll explain this output now manually for you people. Okay. It doesn't matter that visualization comes or not. We'll try to understand this NER output. If you see this output, this S is just, I think it's a start of the sentence. So everything inside this parenthesis is part of the sentence structure, something like that. Okay. But the actual part is this. If you see professor is NNP, OK is NNP, which stands for proper noun singular. We already know that. This means they're recognized as names, but they haven't been grouped into a named entity like a person or place. Okay, that's our observation. Okay, let's observe more. Gave is VBD, tagged as VBD, which means it's a verb past tense. This indicates the action in the sentence, right? So let's see more. Person, Pikachu, NNP. Pikachu, see here the result, it is identified as a person entity. This is done by NER. The NNP tag confirms it's a proper noun, right? For the two, it came as two. Two is tagged to two, which is a preposition or infinitive marker. If you see this Ash, person name Ash, and Ketchum, they both are grouped as a person here, if you see. And both Ash and Ketchum are tagged as NNP as well, indicating their proper nouns. In is tagged to in, which is a preposition. GP, palette, NNP, town, NNP. Palette, town. These two words are identified as a GP group, geopolitical entity, see, which is a type of location. Both words are tracked as NNP, indicating they are proper nouns. On tagged to in, another preposition, a tagged to DT, which stands for determiner. A is a determiner. It introduces a noun. So Sunny JJ, which means it's a tagged to adjective. It describes the noun that follows. Monday NNP, indicating it's a proper noun. However, it hasn't been grouped into a named entity like date, okay, which sometimes happen with days of the week. Now, morning is mapped to NN, tagged to NN, which stands for noun, singular or mass, okay. It's the noun being described by the adjective. In summary, so this parse tree has successfully identified Pikachu, Ash, Ketchum as person entities, okay, and palette and town words as a GP, geopolitical, right? GPS, geopolitical entities, right? So it has also correctly tagged parts of speech like verbs, prepositions, and adjectives in this result, right? So the tree structure helps if you can able to. This is called tree structure actually. This helps visualize how words and entities are related in the sentence. So this is a great example of how Analytica can parse and analyze text to extract meaningful information. So let's see why this matters, why this is that much important. I have added the 3 points here. You can pause the video and read it for yourself. One is for information extraction, search optimization, data analysis, and try it yourself. I mean, like you can add your own example and try the above code again. So in this video, let's recap what all we learned. We imported Analytica, created a sample sentence, tokenized the sentence, tagged each word, downloaded an additional Analytica data needed for NER, performed the name entry recognition using any chunk, visualized okay, this part we did not do. This you can try at your end. I felt it's not much important at this moment to explain NER. Explore the output to understand the entities recognized. This is very important point. We have very clearly understood, right, each and every output of the tree structure, which explains the actual process of NER. Okay guys, let's come to the conclusion. So you have just taught your computer to read a sentence and pick out the names of people, places, and dates, just like a magic, right? How we saw in the example. Feel free to integrate this into your projects, whether it's for analyzing text data, building chatbots, or just impressing your friends with your NLP skills. So thanks for joining me on this video. If you found this helpful, give a like and don't forget to subscribe and share for more videos on this programming and data science and artificial intelligence. Happy coding.